Hello everyone, welcome back to the solutions for the ACET 2024 December paper. We are solving the math section and we're at question 17 to 18. Question 17 can seem like a bit difficult to you because there are three calculations embedded into the problem, but we will not do the calculations. Alright, so first of all you have to look into what the integration is given to be. It is 0 to pi cos x dx. Now how does cos x look like between 0 to pi? It looks like this. Okay, this will be a better drawing, right? This is plus 1, this is minus 1, this is plus 1, and the area between these two portions will be 0, right? Because you have a positive portion here and a negative portion there, and these two are symmetric. These two are symmetric about pi by 2 because cos pi by 2 is 0, right? So 0 to pi by 2 you have a quadrant, and then pi by 2 to pi you have the same quadrant in the negative y-axis, right? So when you calculate the area, you would add the positive part and the negative part and get the final answer of 0. So this symmetry is extremely important. This symmetry is important because we would just be looking into what each method does. Trapezoidal rule approximates the integral by dividing it into subintervals of equal width, right? So for a periodic function, the trapezoidal can give the exact result if the interval is symmetric. So is the interval symmetric here? Of course. So trapezoidal rule will give you the correct answer. Fine. Simpson's one-third rule. What does Simpson's one-third rule do? It is exact for polynomials up to a cubic degree, right? Cos x can be very well approximated by a polynomial within the interval, right? So you can use the Taylor series approximation. So cos x will also give you, Simpson's one-third rule will also give you a correct result with cos x. Same thing with Simpson's 3/8 rule. This is also very fast approximation and fast converging for polynomials up to a cubic degree due to the symmetricity and periodicity of cos x. This method will also give you the correct result. Now all of these are because first of all cos x has very powerful polynomial approximations using the Taylor expansion, as well as it is symmetric within the interval. So if it is symmetric within the interval, then all of your approximation methods will yield correct results. So all of these are correct. If all of these are correct, which one is the option to be marked? Option D, right? Because none of them will give you the wrong answer. I hope you understood this. You should not start calculating the value of integral cos x using all three methods to verify. Just knowing the theory of the methods will be enough. Now for question 18 you do have to make some calculations. This is solving via bisection method. Now this was a 2 marks question and this is a 3 marks question if I am correct. Let me double check. Yeah, fine, I was correct. This was a 2 marks question and this is a 3 marks question. So the first one you did not have to calculate a bit, you just have to think. And in the second one, question 18, you would have to calculate for a bit. Alright, so be prepared, do not make any mistakes in calculation. 2x equal to x cube, so fx can be written as 2 to the power x minus x cube, right? Now once this is done, you would have to check the values of the intervals. Now check f1 and check f2. So this will be your starting point, right? Check the initial interval. So f1 will be 2 minus 1 cube, which is 1, and f2 would be 2 square minus 2 cube, which is 4 minus 8 minus 4. So there is a root between 1 and 2, right? Bisect it. This is step 1 or iteration 1, right? So if you bisect it, you get f1. F1 is same as 1 and f1.5. Now we have to calculate the value of f1.5 because that is the bisection, right? So f1.5 will give you 2 to the power 3 by 2 minus 1.5 whole cube. Now this is root 8, right? Square root of 2, sorry, square root of 2 cube, which is root 8. So root 8 would be approximately 2.8. We know that, right? So this is approximately 2.8. The exact 3-digit value is 2.828. So 2.828. And 1.5 cube, 15 cube. 15 cube, you know this as 3375, right? You can calculate it, 225 into 15. So 3375 means you will have 3.375. Whatever it is negative, right? Less than 0. This is larger. Now even if you do not know the value of root 8, you can approximate it as 2.5 also. It wouldn't matter because 1.5 cube is coming to be greater than any value of 2 decimal that you take. So it will always be negative. That means there is a root here. So we'll check step 2 now. We'll check step 2 because our f1 is still fixed at 1, and now we would have to evaluate the point between f1 and f1.5, right? What does that point turn out to be? That point turns out to be 1.25, right? We would have to evaluate this. 1.25 is basically 5 by 4, right? So fourth root. So this will be 2 to the power 5 by 4 minus, we will have 1.25 cubed, right? What will this be approximately? Now fourth root of 16, that will be a bit tricky to calculate, right? Fourth root of 16, which is basically the square root over square root of 16, isn't it? Wait, 2 to the power 5, right? 2 to the power 5 is not 16, it is 32, right? So it will be square root of 32 square root of 32, right? So this is 1.25 whole cube, which you can multiply and check. So 125 square is, I know, 15625. This is 125 square. You just have to multiply this and check. Alright, now how will we get this value? So we just have to get an approximation here. So root 32 we can write it as 8 into 4, right? So this I can write it as 8 root 4, or root over 8 into 4, 4 can come out 2 root 8, or 16 into 2, so that will be 4 root 2. So root over of 4 root 2, right? This is basically twice of 2 to the power 1/4, right? Twice of 2 to the power 1/4, and this will be, okay, this multiplication is much more easier, right? So what will we get? We will get 125 5s are 625, carry 62, 125 2s are 250, and 62 will give us 312, carry 31, 125 6 will give us 750, and 35 785, carry 78. So 625 and 78 will give us 3, right? So 625 and 78 will give us 723, and if I add 72 to this, I'll get 195. Okay, it was 703, so I'll get 195. So this will give me 1.9 something. Okay, so this is 1.9 approximately, and 2 into 2 to the power 1/4. Now we have to decide if 2 into 2 to the power 1/4 will 2 to the power 1/4, this is basically 2 into square root of 1.414, right? Now square root of 1.4, square root of 14, what will that turn out to be? Think about it. Square root of 14 will turn out to be something like 1.1 ish, isn't it? If it turns out to be 1.1 ish, because 1.2 square, that will turn out to be 1.44, right? Now the square root of 1.41, that should be very close to 1.2, so I'll take it as 1.11 something. So this will be 2 into 1 point, approximately 1.19 maybe, whatever it is 1.1 ish, right? And this is minus 1.9, so anyway this portion will be positive, right? I hope the approximate calculations made it clear. So f1 is 1 and f1.25 is positive. So if this is positive, after step 2, our step 3 will start with f1.25 equal to whatever value we get, and the value between 1.25 and 1.5, right? Because we will shift that, so that will be 1.25 plus 1.5 by 2, which is basically 1.375. So we would be having the approximate root as 1.375. Okay, I hope you understood this calculation. This was my first time doing this also, so I generally tend to remember the square roots till 10, but beyond that, no, I don't remember. I just do the calculations whenever, however is needed. Some of that I might make and make a mistake, but broadly the calculation should be approximated. Okay, you can have a slight mistake in, let's say, the large calculation that I did, 195352, there might be a mistake there, but overall it should be similar to 1.9 something. That is what I am going with. If you can go to that point, then you can have an overall approximation. You just need if it is positive or negative. Okay, you don't need the exact value. You would need it when you are going for step 3, but then again, step 3 you don't have to calculate the value, you just need to calculate the value after step 2. You don't need to start the calculations from step 3. Okay, this is why this was a 3 marks question. So spend a bit of time on it, get the correct answer, and you should be golden. Okay, alright, so I'll be ending this video here, but before that, standard reminders as usual. If you want to revise these portions before the test, if you need any help with mock tests, if you need any help with revision classes, crash courses, etc., do contact the numbers given on the banner. The mobile number you see has WhatsApp enabled to it, so you can drop a message to it. You could also write an email with the query to the email ID provided. Our team monitors both of these contact points, so you can expect a prompt response. If you have any comments, suggestion, feedback, I realize I might have made some minor errors in the calculation. If that is the case, then do not hesitate to put it in the comment section. Overall, broadly the calculation should be correct. Okay, because calculating while recording while teaching is a bit iffy. So if that happens, then mention the corrections. I will make sure that they are corrected in the notes, and do not hesitate to contact us for any help that you might need. Make sure that you have liked and subscribed this channel. And with that being said, I'll end this video here. Thank you all for joining, and I'll see you all on the last part, because question 19 and 20 are the last questions from maths. Then you have stats questions and DI questions. Alright, so 19 and 20 will be the last. Thank you for joining. Take care. Bye.